So when we're expanding brackets with surds, the rules that have applied for algebraic terms and binomial expansions are exactly the same, except instead of working with x and y, we're working with the root of a number. But adding, subtracting, multiplying, dividing, it still works the same way, except for one small thing. What we need to remember are those rules that we've looked at earlier. So the root of x times the root of y is equal to the root xy. And root x over root y is the same as the root of x over y, and whenever we square a surd we end up back with the x on its own. So let's have a look at some of these expansions. Root 3 outside of root 5 minus root 3. If you want to write each step out, you're going to get root 3 times root 5 minus root 3 times root 3, which you can then simplify using the rules above to root 15 minus 3. However, you can skip this step once you're comfortable. If you know how to go straight to the answer, which after some practice you will, because we can all do 3 times 5 in our head by now, you can go straight to the answer. That's no problem at all. So if we complicate it a little and we start putting some numbers in front of our square root signs, same deal, works the same way it did before. So 2 root 5 times 3 root 3, well, 2 times 3 is 6. And then 5 times 3 is 15, so that's 6 root 15, and then 2 root 5 times root 5. So think about that for a moment. Root 5 times root 5, well, that's going to be equal to 5. And then we've got 2 of those, so 2 5s are 10. Okay, so here's a binomial expansion for you. You can still use your FOIL technique, okay? First the outside, the inside, and the last. So root 3 times root 7, well, that's root 21. Then we look at the outside terms, so we've got root 3 times negative root 5, so that is negative root 15. Then we look at the inside, so 2 root 5 times root 7, so that is 2 root 35. And then we've got 2 root 5 times negative root 5. Well, we just looked at the fact that root 5 times root 5 is 5. So this term is equal to 10. And when you get to that point, you need to stop and have a look and say, can I simplify it? In this case, I can't. 15, 21, and 35 don't have any square numbers in it, so we stop there. Now, before we look at number 4, I want you to consider what you would do if you had a question that said x plus 3 times x minus 3. What do we get? Well, we should be pretty comfortable with the idea, well, that is x squared minus 3 squared, so we get x squared minus 9. Have a look at that, compare it to our next example, root 5 plus root 3, root 5 minus root 3. We should all know by now that we're going to get the square of the first and we're going to get the square of the second, because the plus and the minus are going to end up cancelling each other out. So what we're going to end up with is root 5 all squared minus root 3 all squared. And what does that cancel down to? Well, whenever we square the square root, they disappear, leaving us with 5 minus 3. So the answer for this one is 2. It's very important to understand this one, because when we start rationalizing denominators, this fact becomes very important. Okay, so when you're having a look at exercise 2.22, from questions 1 to 3, you can do as much as you like. Okay, so if you're really good at these, you know all of your square numbers and you don't need lots and lots of practice on them, then you can skip over them, that's fine. But from question 4 on, I want you to do all of them, because it's really important that you understand what's happening here, okay? See you in class.